Believe it or not, this is the same type of experiment as we showed 2 slides earlier. Instead of looking at the phage population growth, however, and ultimate yield, instead we're looking at the phage impact on the bacterial population. So the bacterial population is growing, and we've added the phages, and the phages are infecting the bacteria. So what we have here is at this point, which is essentially a 0 point for the phage infection, is the addition of a low multiplicity of phages. So there's a lot more bacteria than there are phages. The bacterial population continues to grow, but the phage population does as well, infecting, lysing, releasing progeny phages, which then go on to infect new bacteria. Now, these populations grow and grow and grow until all of the bacteria within the populations are infected, and then the populations are lysed, which is what these drops represent. Now, as the phages are growing their populations, the bacterial population is growing, the more slowly the phage population grows, then the greater the density of the bacterial the bacterial population can grow to, and also the longer that the bacterial population can grow. The greater density ultimately results in more phages being produced because more bacterial cells are being infected. And the longer time the bacteria go before they're in fact lysed by the phages is a measure of the virulence displayed by the phages against this population of bacteria. So this is a clonal population of bacteria, and they display a certain amount of health that is a function of how many cells are present, and the peaks up here represent the maximum amount of bacteria present. And so the more virulent phages are the ones that are lysing these population of hosts sooner, and the less virulent ones are lysing the population later. This clet turbidity, the turbidity of the culture, basically is a measure of how many bacteria are present and or the size of those bacteria. This sooner host lysis is corresponding to a population of phages that displays higher virulence. The Sta5 is the defector, cheater phage type. And in fact, not only are we seeing these phages that are more virulent lysing the bacterial population sooner, but even when you've got these phages growing in the same culture as the wild type, they're lysing the population of bacteria sooner. And this is the same as we saw 2 slides earlier, where the mutant was able to outcompete the wild type by growing its population faster and therefore dominating what's going on in the environment. Now, over here, we have a phage that's the wild type phage, the cooperator. It's displaying a lower level of virulence. Its population grew more slowly. As a consequence, it allowed the bacterial population to grow for longer. The bacterial population, in a sense, was less sick. And this also has the advantage for the phage in allowing the bacterial population to grow to a higher density, which results in more phage infections and therefore more phages produced. And what we have right here is a third type of phage that happens to display a slightly greater virulence than the wild type, and this phage is lysing the host population a little bit earlier. It's displaying a greater level of virulence. It also displays a slightly shorter latent period and a slightly smaller burst size than wild type, but not nearly as short or not nearly as small as the Sta5 mutant displays.